Density. What weighs more, a pound of feathers or a pound of bricks? This is a silly question, since they're both a pound. Sometimes people say that iron is heavier than wood, but if you have a log of wood, it would be heavier than one small iron nail. What we should really say is that iron is more dense than wood. Density is the ratio of mass to volume, or the mass per unit volume. In many ways, density is more valuable than either mass or volume separately. That's because often the volume and mass aren't important, just the ratio of its mass to its volume. It's density. As we study climate, weather, and even the crust of the Earth, density will be a critical factor. Density equals mass over volume, or D equals M divided by V. Any ratio of mass to volume can be used to derive a unit for density. Two units for density which we will be using are grams per cubic centimeters, or G over cm cubed, and since 1 milliliter equals 1 gram per cubic centimeter, grams per milliliter. These units are especially useful since, by definition, the density of pure water at 4 degrees Celsius, or 39.2 degrees Fahrenheit, is 1 gram per cubic centimeter, or 1 gram per milliliter, or 1,000 kilograms per cubic meter. As we will learn, the density of water changes with temperature and if salt or other material is dissolved in it. This definition is only exactly true for pure water at its densest temperature, 4 degrees Celsius. By the way, making the density of water equal to 1 gram per milliliter when they invented the metric system in 1795 is another reason it's so easy to use. As a result, anything with a density below 1 gram per milliliter will float in pure water at 4 degrees Celsius. Anything with a density higher than 1 gram per milliliter will sink. This is true for solids, but also for other fluids. For instance, salt water has more mass than pure water, since the salt adds mass but not volume. So salt water will sink in pure water, which turns out to be important. But more on that later.